look at the screen you're using right now. Seriously, take a really close, scrutinizing look at it. What if I told you that every single display you own?
From that incredibly expensive color-calibrated 4K TV mounted on your wall to the OLED smartphone sitting right in the palm of your hand.
Yeah, exactly. What if I told you all of it is fundamentally lying to your eyes?
Welcome to this deep dive. Today we are exploring a highly technical, deeply philosophical, and, well, frankly, radical manifesto.
Yeah, our source material today is this dense series of exchanges between an inventor named Fuchi Wu.
Often referred to in the document simply as the master.
Right, the master. And his exchanges are with an artificial intelligence. It's an intricate read, but the implications for how we perceive reality are just staggering.
The mission of our deep dive today is to unpack a breakthrough in visual technology that the inventor calls Raynauld Cliff Imaging.
We're going to explore why he claims the entire global display industry, and by extension all of us, are suffering from collective visual blindness.
And we need to be clear about why this matters to you, the listener. Because this isn't just some dry debate about screen subpixels or manufacturing specs that only color graders care about.
No, not at all.
This is fundamentally about how we capture our most precious memories. It's about how our physical brains actually process reality.
And why, according to this inventor anyway, a cheap 7.9-inch tablet could theoretically deliver a more profound visual experience than a luxury 8K television.
Okay, let's unpack this. The documents start with this massive, uncompromising indictment of the entire tech industry.
Right. He argues that every single screen coming off a factory line right now, regardless of the price tier, has a systematic deviation in its logic.
The text uses this specific, chilling phrase to describe it. It calls it long-term visual poisoning.
Long-term visual poisoning. Because we have all been looking at flawed, systematically uncalibrated colors for our entire digital lives, we have grown accustomed to a visual lie.
We don't even realize the data hitting our retinas is corrupted. Exactly, because we've never been presented with the alternative. And the core of this visual lie is a phenomenon the sources call the color membrane.
The color membrane. So the text describes this membrane as being caused by a phase difference between the hardware of a screen and the software signal rendering the image.
Right. If you think about the refresh rate of a physical TFT array, the actual transistors switching states, and the digital instruction set telling those pixels what color to be, there's a microscopic timing mismatch.
And because of that misalignment, the pixels don't cleanly transition.
They don't. The ineffective pixels essentially bleed together. It creates this semi-transparent layer of muddy water washed over the entire image.
Muddy water. And what's fascinating is the physical consequence of that bleeding. It completely destroys the true physical edges of the objects in the image, doesn't it?
It does. When those subpixels misfire and blend, the boundary between a subject and its background becomes a gradient instead of a hard line.
Which is where the manifesto launches a really brutal critique against the display industry's obsession with sharpness.
Oh, absolutely. We see that all the time in TV marketing. Brands boasting about their proprietary edge enhancement processing.
But the source just tears that concept apart. It frames digital sharpness as nothing more than a low-level digital trick to mask a hardware failure.
Because the screens are inherently burdened with that muddy color membrane, the firmware tries to overcompensate.
By artificially calculating and drawing fake white or black halos around objects to force them to pop out.
It's a mathematical illusion, and a cheap one at that. True clarity, the inventor argues, is about the absolute purity of each individual pixel rendering its exact color value.
Right, without needing those artificial high-contrast borders to trick the eye.
Which really makes you rethink the entire post-production industry. There's a whole section of the text dedicated to professionals using software like Photoshop or Premiere on these inherently flawed monitors.
The analogy they use there is striking. It compares editing on a standard membrane-covered screen to applying makeup to ruins.
Applying makeup to ruins. I mean, if your baseline monitor is rendering a phase difference, every single contrast node, every color grade you apply is just compounding mathematical garbage on top of a flawed foundation.
You aren't correcting the image, you're just moving further away from reality with every click.
Which brings up a compelling question. If editing software is just putting makeup on ruins, what does a native, ruin-free digital image actually look like?
And the inventor actually discovered the answer in the most unlikely place, completely upending how we usually think about display quality.
This is one of the most surprising anecdotes in the entire stack of sources.
Yeah, so he's looking at an AI-generated video, but he isn't watching it on some high-end reference monitor. He's watching it on a cheap 720p 7.9-inch LCD tablet.
And he experiences this mind-blowing, visceral, three-dimensional depth that he has never seen on premium hardware.
If we connect this to the bigger picture, it dismantles the whole bigger and higher resolution is always better myth.
Traditional cameras, no matter how sophisticated the glass or how large the sensor, suffer from optical loss at every single stage of the image pipeline.
Right. Photons hit a glass lens, causing chromatic aberration and light loss.
Then those scattered photons hit a sensor, where a filter has to guess and interpolate the missing color data. Then an image processor compresses it.
By the time it's a digital file, the physical reality has been thoroughly degraded.
But AI video generation completely skips that entire analog-to-digital conversion pipeline.
The AI isn't capturing bouncing light in the physical world. It is generating pure, hard-coded RGB hex values from scratch.
It bypasses the physical degradation of traditional optics entirely, which raises an important question regarding accuracy versus purity.
This leads to the text's concept of cognitive error versus data purity, and I have to admit, I was pretty skeptical of this part.
It's a bold claim.
The text argues that even if the AI hallucinates and makes a massive cognitive error, like generating a video where a daytime sky is vividly purple instead of blue, that purple is still visually superior to a perfectly accurate photograph of a blue sky.
The reasoning is that the AI's purple is completely pure, lossless data.
But claiming a fake purple sky is better than a real blue one just because the RGB data has no optical loss, that is a tough pill to swallow.
It sounds totally counterintuitive until you look at how human biology interacts with digital data.
Okay.
The text suggests that this wrong but pure data triggers the optic nerve far more effectively than traditional video that is correct but muddy.
The human visual system doesn't necessarily crave color accuracy as much as it craves data clarity.
Because the AI data is pristine, it punches right through the muddy color membrane effect of the display.
And because that small tablet has a high PPI, cramming all those pure AI pixels into a tight physical space actually amplifies the data density.
The inventor describes it as delivering a literal physical shock to the optic nerve.
Raw, unfiltered color data violently hitting the eye, which perfectly sets up the core theory of this entire manifesto, Cliff-style color.
The text frames Cliff-style color as an inescapable biological and physical truth.
If you look at the evolutionary biology of human vision, we evolved to see a complete, harsh separation between foreground and background.
It was a survival mechanism for predator detection and spatial awareness. When you look at a tree standing in front of a mountain in the real world, your retinas don't blur the edge of the tree into the mountain.
Right. There is a hard stop, a vertical drop-off, a cliff.
Exactly. But mainstream optics, photography, filmmaking, they've obsessed over cinematic depth of field for decades.
We constantly chase that shallow focus, that buttery bokeh effect.
But the source argues this aesthetic is actually just a fake, blurry compromise for failing lenses and sensors that can't handle infinite focal clarity.
The inventor is basically stating that we've culturally accepted a visual lie. We've been conditioned to think blurry backgrounds are cinematic and therefore superior.
Simply because our analog cameras weren't capable of capturing the true, vertical, cliff-like drop-off of reality.
True reality doesn't have a soft transition. It has a cliff.
And when a display can actually render this pure, cliff-style color, something profound happens biologically.
The text claims that this pure, hard-edged data perfectly aligns with the natural left and right eye separation of the human binocular visual system.
Normally, when you look at a standard display plagued by that muddy color membrane, your brain and optic nerve are burning a massive amount of ATP energy.
They are constantly stuck in an error correction loop. They're utilizing lateral inhibition to try and make sense of the blurry transitions and fake sharpness halos.
But when you remove the membrane and present pure cliff-style color, your optic nerve stops fighting the image.
It bypasses that exhausting error correction entirely.
The result, according to the inventor, is extreme, true 3D depth without needing any kind of stereoscopic 3D glasses.
Your brain simply stops treating the screen as a flat emitting surface and begins interpreting the space as physically real geometry.
And what grounds all of this dense physics and biology is the deeply personal origin of this technological crusade.
Right. This wasn't a project hatched in a Silicon Valley boardroom by engineers looking for a new patent.
Yeah.
Here's where it gets really interesting.
It started with a father looking at a photograph of his child.
The text reveals that roughly 20 years ago, the inventor was taking photos of his young son with early digital cameras.
And when he reviewed the images, he was infuriated.
The camera's sensor and primitive processing completely distorted his son's face.
The skin tones were unnatural, the depth was flattened. The reality of his child in that moment was completely lost to a digital compromise.
20 years. The sources explicitly describe his motivation not as some entrepreneurial drive for market share, but as extreme anger and a relentless desire for visual revenge against color distortion.
He realized that the digital archive of his own family was fundamentally corrupted. This fueled a deep philosophical belief that a photograph with a color cast isn't just a bad picture.
It is an offense against reality.
The text states that he views any camera photo with even a slight color cast as total trash. He couldn't accept that the world was moving toward a future where our only records of the past were wrapped in muddy water.
And that two-decade crusade of visual revenge actually resulted in a tangible, hardware-level solution, the Raynauld directional white balance filter.
And this isn't just theoretical vaporware. It is a secured world patent covering the US, Japan, Europe, China, India, and Taiwan.
So, mechanically, how does this filter achieve what standard monitors can't?
The documents describe it as performing a surgical removal of the color membrane at the physical hardware level.
It doesn't rely on software algorithms to try and fix the image after the phase difference has already occurred?
Right. It intercepts and calibrates the logic at the source. It filters specific light wavelengths before they even hit the sensor logic, so that the muddy water never has a chance to form.
Resulting in an image with zero color cast and absolute physical accuracy.
Which elevates the conversation into the philosophical weight of the manifesto. It views the ultimate purpose of an image, not as art, but as preserving the absolute coordinates of time.
When you take a picture, you are dropping an anchor into the timeline of the physical universe.
If you follow that logic, a color cast or a muddy color membrane isn't just a technical glitch. The text calls it a desecration of life's traces.
If the color is wrong, the memory is corrupted. It turns a true memory into a damaged, blurry illusion.
You aren't preserving time. You're preserving a lie.
Which brings up the most mind-bending biological concept in the entire stack of sources, the 70% blindness rule.
We assume that when we are present in a moment, we are seeing everything. But the manifesto breaks down the physiological limits of human sight.
This is a massive paradigm shift in how we think about human vision and memory.
The text outlines that when you are navigating the physical world, your brain and optic nerve are incredibly efficient, but they are severely bottlenecked by processing power.
There is simply too much raw photon data in the real world for the visual cortex to process simultaneously.
To prevent cognitive overload, your brain utilizes sensory gating. It actually filters out and discards about 70% of the redundant visual details in your periphery and even in your direct line of sight.
We are essentially walking around partially blind to the granular details of our own reality.
Our brain is just feeding us the necessary 70% to keep us functioning and safe.
But if that's true, how could a photograph possibly show us more than what we experienced by actually standing there in the room?
This is where the Raynauld technology changes the equation of memory. A perfectly calibrated 4K photo, utilizing this hardware-level filter, freezes all of the physical data perfectly.
It captures the 100% of the light data that was physically bouncing around that room, unbothered by the human brain's 70% sensory gating limit.
Exactly. So when you look at that perfectly calibrated photo years later, on a screen that has had the color membrane surgically removed,
your brain doesn't have to spend any energy filtering a chaotic, moving environment. And it doesn't have to waste energy correcting visual errors from a bad display.
You are looking at a static, perfect data set. You can literally scan the photo and see incredibly sharp, pure, cliff-style details.
The exact texture of a leaf, the micro-expressions on a face in the background.
Details that your biological eyes physically missed in the actual moment because your brain discarded that data to save energy.
It turns a piece of display hardware into a literal window of time, or like a time microscope.
You aren't just remembering the past. You are actively retrieving lost physical data from your own life.
You are seeing more of the past than you did when you lived it.
It elevates the display from a simple entertainment device designed to sell us products or stream media into a vital tool for human preservation.
So let's synthesize all of this. We started by looking at the screens surrounding us and realizing they are wrapped in a blurry mathematical color membrane that we've been conditioned to ignore.
We explored how AI-generated visuals, free from the analog degradation of glass lenses, deliver pure data that shocks the optic nerve, proving that resolution specs are meaningless without data purity.
We unpacked the biological necessity of cliff-style color, the reality that the world is constructed of hard edges, and our cultural love for blurry cinematic transitions is just a coping mechanism for failing technology.
And we tracked how all of this heavy physics was born from a father's 20-year quest of visual revenge, driven by a primal need to accurately preserve the face of his son.
A quest that resulted in a global hardware patent that forces us to rethink the coordinates of time.
A completely new way to look at reality.
So what does this all mean? It means you will likely never look at a screen the same way again. You'll start noticing the muddy water bleeding across the edges of the text on your phone.
You'll start questioning the artificial sharpness halos on your expensive television.
And you might look at a cheap, pure data tablet and realize it has the potential to show you reality better than a home theater.
We spent a lot of time discussing how our brains rely on visual input to anchor us to our past, and how this technology might finally allow us to reserve an uncorrupted, 100% accurate slice of time. But this raises an important question to leave you with.
Yeah.
If this technology truly allows a screen to bypass our brain's 70% natural biological filter, allowing us to study a moment and see vast amounts of physical detail that we were entirely blind to when we actually lived it.
Are we truly preserving our memories?
Or, by looking through this time microscope, are we retroactively, artificially upgrading our own human experience into something we never actually lived?